So, like Kobe said, my name is Jeremy. I've been with ATTi Interactive for 4 years now. Started out on their website team. At the time, it was a very small team, and it grew very quickly. I'm now on the applications services team, which essentially what we do is we build service applications for the website, for the mobile consumers. Basically, anyone who wants to get Yellow Pages data has to go through us. And so when the services team first started, it was, like I said, 4 years ago, maybe 5 years ago actually, and it was back when Rails was great for everything, and so of course the service got built in Rails, and it was fine. It's been fine until we started getting a lot of traffic. So I kind of wanted to just share my experience with you guys about what it's been like working on just a web service written in Ruby and how to stick with it, because we really didn't want to rewrite this in something else. So scaling a web service in Ruby. Basically, we're going to go through how we go from something that can handle a few 100,000 requests a day to something that can handle several millions of requests a day. Right now we're handling upwards of 3 million requests a day. That's about 200-something thousand requests per minute. And so, yeah, so the main thing I want to emphasize in this talk is that language, the language that your web service is written in, is probably not that important. We use Ruby because we like Ruby. We have experience with Ruby. And the reality is, if you have done your architecture pretty well, your web service is really just a gateway to other services or applications in the back end. So you shouldn't really be spending much time at all, hopefully, in the service that you write. You just want to pass things through one way and back out the other and not hog anybody's time. So, first thing I want to say is Ruby is awesome. You know, I love Ruby. It's a great language. For all the quirks that it has, it's really easy to use. It's very descriptive. You know, it's very kind of low introduction point, really. So, you know, new developers can catch on really quickly. Developers who haven't done Ruby, who are good, can catch on very quickly. And it's actually one of the faster interpreted languages out there. And if you count JRuby and MacRuby, even Rubinius in there, it's actually pretty fast. So just because the language is rarely the bottleneck doesn't mean that the way you use it isn't the bottleneck. And that's actually what our experience was. So what does your typical Ruby web app look like? Like I said, it's usually written in Rails, and most Rails applications, just from the outside, kind of look like this. Right? You have you have this guy, and he's really nice, and he really helps you out. But you know, there's only so much he can do, and he takes up a lot of room. So, you know, large footprint is pretty typical. I don't know if you've looked actually at the memory that your Rails app takes. For us, we got to the point where when we just boot up the application, it would take just one Ruby instance would take about 350 megs. Now, if you have a server with even 8 gigs, you know, you do the math, you can't get that many Ruby instances running on there. It has a single track mind, so it can really only do one thing at a time. It's single-threaded, usually. And so you give it a request, and you know, it can only handle that one request. And we'll look at it a little bit later. And it's really not very good, usually, at communicating. You know, you have you know, NetHTTP, and it's a great tool, but it's often way underutilized. You can do so much more with it. There's a lot of gems that do HTTP communication. that are really good at performance and stuff. But basically, when you're talking to those other services, you don't want to stop everything you're doing and wait for a response. So, real quick, just to kind of emphasize the point, you get a request into your application, and he looks at it, he's like, okay, I need to go get some resources on the back end, so kind of pushes out, and then he just waits, and waits and waits and waits, and oh, I got something, all right, cool, I'll build this nice little package thing for Ruby apps. It's usually like some form of JSON. And Rails is really great at writing strings, right? It's really great at packaging things up, making like really fancy outputs, and you push it out, and by that time you have like a bunch of other requests that are just waiting there, and that's really not a very effective way of just handling traffic. So usually, so for us, the actual server usage looked like this. You have all your VRAM is being taken. You're probably swapping at some level because you're taking all these requests in and firing all these objects up and then throwing them out, and the garbage collector is running like 3 times the request. And you're really not using any CPU. Your app is just waiting and consuming all this memory. And the typical way that Rails and Ruby apps have been scaled is, you just put a bunch of instances up on the server, as many as you can fit, really. And you have something like mongrel, thin, or unicorns in front of it. And when you run out of space that way, what do? You just have a bunch of servers running unicorns, and that gets very expensive very quickly. And there are other ways to scale Rails apps, like using elastic clouds and stuff like that, but that's also extremely expensive. So the idea here is that we want to reduce the amount of RAM that the application is taking, so we can run and increase the concurrency level so that we can run a lot more requests through it. And we also want to make sure that we're not spinning our wheels in the Ruby application itself. All right. So how do we fix it? Like I said, reduce memory. You want to keep Ruby busy. You don't want Ruby to do busy work, but you do want Ruby to actually do stuff instead of just sitting there and taking up all your memory. And you want more efficient I/O. So the first step is slimming down your app, right? How do you do that? Well, I think the previous talk actually illustrates that perfectly, right? I was only going to touch on it a little bit here, and it's great that it's been talked about. First of all, you want to reduce the amount of code in your app. Now, how many of you have worked on a project for more than a year? Okay, more than 2 years. Okay, after a year or two, you have code in there, you don't even remember why it's in there, right? It's like, oh, well, this project was running back then, and we had to have like this feature, but you don't even know if it's really being used anymore, and you have all this extra code, probably a bunch of classes in there that get booted up with your app that are hardly not even getting used. And one of the kind of neat things that we've done, just to kind of look at usage, is we've tied in some profiling things like R code, for example, simple code, right? And we've actually put it on our app at runtime, or not in production, of course. Put it in our app, and then we run logs against it. Run a day of logs against it. And it's actually a really neat way to see, okay, are these endpoints actually getting used? Is this model ever getting hit? And so you'll be able to at least start the process of getting rid of things that are just sitting around for no reason. avoid creating a lot of classes. I can't emphasize this enough. And this is one of the things that is a little bit frustrating about Rails. Classes take up a lot of memory in Ruby. And I found this little snippet, and it's basically creating 120,000 classes, and just an IRB, and the memory usage jumps to 41 megs right away. The garbage collector doesn't garbage collect classes because they're classes. So, those things aren't going away. I actually tried to run this on my own machine, Ruby 193. It was 70 megs, it wasn't 41 megs. So that's definitely one thing where you can cut down. And then objects that you're gonna reuse a lot, things like regexes, just put them in constants, try and reuse them. Don't instantiate new objects if you don't have to. Just some general memory management guidelines there. Just because Ruby does all your memory management with the GC and all that, doesn't mean that you don't have to worry about memory. It's actually the opposite. You have to worry more about memory because you don't have kind of that control. Avoid singletons and monkey patches if you can. Those things, especially if you're doing like instance evals, stuff like that, you're basically creating a new meta class every single time you do an instance eval, and that grows and takes up a lot of memory very fast too. So, of course, the next thing is you probably have a bunch of dependencies, and all of the rules that you apply to your code, you should apply to your dependencies as well. You want preferably to use only very small gems, and that means probably not Rails. If you're creating a service, Rails is really great at writing HTML, right? It's really great at reading forms, but it's not really great at the rest. So since you're only really going to be writing JSON or they'll help you XML or something like that, you don't really need that very fat view logic in there, right? You just need like the JSON gem, or maybe YAJL, which is a little bit faster. Just a little quote I found on Mervis about the GC specifically. After warming up a basic Rail 3 hello world, so there's nothing in there. App clocks at about 8,500 objects allocated per request. It's every time you make a call. Create 8,500 objects. Forcing the GC to run more or less every 6 requests. That's for something that doesn't do anything. On my machine, the GC takes about 20 milliseconds to free the objects. The Rack Hello World app clocks at 7 objects per request, and the Sinatra app's at 181 objects. Right. So, talking about what Jeff was talking about, this is a perfect example of an easy way to reduce the amount of time you're spending in Ruby on trivial stuff, right? So we use Sinatra. There's probably like a million other, rack-based frameworks that you can use. Find one, profile it, take a look at it, and see if it works for you. So, yeah, profile and replace your dependencies as you need. We don't use things like active record, although active record is really nice for a lot of things. We try and not do a whole lot of DB stuff. We try and put that in a separate app. So we use a SQL gem, spelled SEQUEL, and that's pretty good. And just because you don't use Rails doesn't mean that you can't use some things in Rails. Active support has done a lot of really great work in being able to require only parts of active support, so you're not loading, the whole thing. Active support is a beast. I mean, it's a lot of stuff in there. So you want to, require only the things that you're going to use. So CPU usage. Most of what your app does is nothing really. And so what we've done is gone from this to, okay, now maybe we can do this. Like we just have a bunch more of slow applications and instances running on your server behind a unicorn. And we still have this problem, right? Client talks to the app and it's waiting, and then the app talks to the backend and it's waiting, and it waits until it can return. What we want is to be able to do this. Keep the app busy, talking to the backend, and talking to clients. So how do we do that? Concurrency in Ruby web apps works great. And we use a server called Rainbows. If you haven't heard of it, it's awesome. You should try it out. It's really great for highly concurrent applications, and it's really great for also if you want to do anything with like slow running requests, such as image uploads, stuff like that. You can it'll do streaming. It'll do a lot of really cool things. We do multi-threading, and we use a thread pool management system for the threads. This comes built into Rainbows, and what it does is basically Rainbows will only spawn however threads you want it to. We use 16 per process, and it'll just hold on to them. Thread spawning can be pretty expensive in Ruby, especially in Ruby 1.9. So if you can hold on to those threads, that's generally best. Now, it's important to note too that most of what you do in a Ruby application hopefully is easily made thread safe. Usually, you don't really need to share anything across your threads. So hopefully the move to multi-threading is pretty easy. Most of the gems are actually thread safe. So you just, we've run across a couple that weren't, but you just have to be careful. So, of course, if you know anything about multi-threading in Ruby, you know that it's not true concurrency, right? It's because of the global interpreter lock in Ruby 1.9. You have to basically, kind of share still the time that is running between your app is running between multiple threads, and so it's only kind of concurrent, really. But the reason multi-threading works in our case is because Ruby 1.9 has this great feature where it has evented I/O. So every time you make a request with a TCP socket, for example, Ruby will release the lock for that thread. Essentially, it won't care about that thread until it waits for the OS to tell it, hey, I have some data you need to read here. So what that means is that all the other threads have a lot more CPU time to run. And so in that sense, you have concurrency, true concurrency, when you're doing backend requests. The other thing to note is that not all Ruby interpreters have a global interpreter lock. So if you're using JRuby, or if you're using MacRuby and Rubinius 2 now, none of those have a global interpreter lock. So you could have true concurrency that way. So what does an app look like with thread pooling? It looks like this. You have a bunch of clients, all goes through Rainbows. You talk to your threads, and those threads talk to your backends. And basically, if you have 16, 20 threads per process, that's 16, 20 times more connections that you can handle than you could before, with virtually no added memory. So, because all the requests are using the same Ruby space, you're able to scale very, very quickly with almost no extra work. So that's great, but you want to make sure that your app is not slow while getting other requests. The danger that you get into now is that your back-end servers, for some reason, one of them becomes really slow. It goes down or it loses half its instances. And now when your threads are calling that server, they're getting caught up, right? And eventually it takes down your connections and your app just goes down. And that's something you don't want to do, And so one of the reasons why a backend could be slow is just, the sheer amount of data that we're returning. You want to have as little data as possible circulating at a time if you can. We have instances where, unfortunately, our backends return blocks of 600K at a time, and we're working on that right now, both to reduce the amount of data, so the amount of content that we're requesting, but also using gzip and things like that. So using gzip will actually be a lot faster above a certain threshold of data than actually transferring all the information uncompressed. So compressing, transferring, uncompressing is faster than not compressing and passing 600K of data through your wires. And this is all things running in the same data center too, so gives you an idea of how much time that can take. Keep your connections alive to your backends, right? So you're probably familiar with how TCP connections are made. You do a DNS lookup, and then you try and establish the connection, and then you're like, okay, I got the connection, now I can start doing work on this connection, right? Most Ruby web apps don't use persistent connections. And that's a shame, because that whole first section right there can easily take up to 5 to 10 milliseconds to 10 milliseconds. Depends on what service you're trying to call, if it's something external, if it's if you're trying to talk to Google Maps or something, or maybe it's a service from some smaller company and they really have no idea how to make their application available quickly. So just think of 5 to 10 milliseconds every time. Not only every time you make a call, but for every single service that you're calling, you can multiply that. In our case, we make dozens of calls to our backend, so that will quickly grow to 100 or more milliseconds right there. And then there's this great thing called pipelining in HTTP, and this is really only if you're making a bunch of calls to one server. So we have some Tokyo Tyrant servers that we talk to a lot, and we store documents in it, and we retrieve 30, sometimes more at a time, and so we use HTTP pipelining for that. And what it does, so first, if you were to do it just without pipelining, it would look like this. You make a request, you get your first item back, and you make another request, you get your second, and so forth. Pipelining works like this. You just say, I'm going to send you all the requests I need, and most HTTP 1.1 servers will support this. And then it'll do its thing, and it'll return all the responses at once. And you can see it's a lot more time efficient. Now, if you are really hardcore, and we don't do this for good reason, so I'm warning you against this, but if you really, really wanted concurrency and really fast requests, you could just parallelize the all the requests you make to different backends if you don't need them to be synchronous or in any particular order. And you could just say, okay, I need this from this service, this from this service, and I don't need to know anything between them. I'm just going to fire both of them at the same time, get all my responses at once, and then process that. But like I said, it's a little bit hardcore, and it may not be what you want to do, especially because then you really do start getting into some issues with multi-threading and management of resources across multiple threads. So you don't want to get into some deadlocks there on your app because you'll get some very bad things. The last thing about connections is you just don't want to wait around. If a backend server is taking 2 seconds to respond, you're not going to do anyone a service by waiting for it to return, right? What's going to happen is everything that's going to call it is going to eventually get slow. And it kind of looks like this, right? You have your fast endpoints, and think of all your threads as handlers, right? You can handle 4 connections right now. Your first request will come in, and it's for that slow endpoint. Okay, this guy's busy now. So you've just yanked a quarter of the amount of handlers that you can use for other requests. And right now you're fine, everything's going through there, but it's going to be inevitable that things are going to start piling up. You're going to get another request to that slow endpoint, and it's going to block half of your connections, and then another one. And eventually, your app is going to get really slow because it only has one worker left to handle all the endpoints, right? So it's much better to just kill the connections, kill the requests on your back end. And then you'll have, a fast endpoint again. It'll fail a lot, but it's not really your fault, right? It's, those guys that own this other service should fix it. And you want to make all the other endpoints available, even if just one of your backends is trying to hog some time with responding to you. And so everything will be nice and happy. Now, if you have long-running endpoints, and that's just the way it is, and you can't make it any faster, maybe you're doing like an image upload service or something like that. Then just break it out into its own application and add more handlers in front of it. Let it do its thing, but don't mix slow connections and fast connections on your same application, right? Don't have slow and fast connections from the same connection pool, because the slow connections are going to win. They're going to take down all the resources eventually, and then you won't know, you won't know what to do with all the traffic that just wants, just a little bit of information. So, just a few things to avoid when you're doing this stuff. The things that we run into, you want to avoid too many connections to your backends. The first thing that happened when we deployed this application is people came to talk to us and they said, "What are you doing to us? You're taking down our servers." Essentially, we had made the app with such a large pipe because of the persistent connections. We're connecting 3,200 connections to each service, that is persistent, and keeping those connections open. So you kind of have to be careful who you keep open connections to. And for internal stuff, it's usually fine. It's just a setting in Linux. You say allow more connections. But for third-party backends, it might be more tricky. For us, one of the ways that we handle this is we do some sort of thread pooling. So we say we have like this many connections open for this service, and because you're never going to have all your threads needing a connection to that service at the same time, you just say, just give connections out to different threads based off of what they need. And then when they're done with it, they return it to the pool. Now, I kind of want to apologize for this next slide. I've never been to New Jersey, but hopefully nobody will keep this against me. All I know about Jersey is the Jersey Shore. So, avoid bad state by discarding timed out connections. We've had this issue with specifically just raw TCP connections, so no HTTP, and with database connections. We time out everything, like I said, killing slow connections. And if your socket is in the middle of writing something or reading something, maybe it has a buffer, and the buffer has some data that's left over in there. And if that happens, you'll often get into a bad state. Your connection's kind of hosed. You can't really write to it. You can't really read from it. You'll get some garbled stuff. So when you time out a connection or one of those slow connections, you just want to throw it out and reconnect. It'll save you a whole lot of pain. It's not as fast, but it's better than being fast and failing all the time. And then, of course, standard thread safety principles. I talked about pooling, but for connections. But if you don't have to do that, don't do it. It introduces just a whole world of pain, possibly. Don't share anything that you don't have to across multiple threads. If you're anything that's going to change, basically. If it's just reading, it's fine. If you're going to be writing to objects and changing objects, try and keep those local. So wrapping up, what we talked about: reduce your memory, use rainbows, use efficient I/O. Just to show you that it's not a bunch of crap that I'm trying to feed you. This is the application before. That's the application after. And you can see we were handling connections at about 115 milliseconds on average per request. Lots of backend time. The green is the backend time. Light blue down there is read time. We could handle about 66,000 RPM max, and that was a total of 900 connections across 30 boxes in our data centers. With all these changes we've made, we're running 10 boxes. We have 3,200 available connections. We're only using about 100 megs per instance, which is great. It's like a third of the Rails app that we were running. And we've gone up to 300,000 RPM without breaking a sweat. We don't see any spikes, really. We're kind of waiting to see what the limit is, but our CPU usage is probably about a quarter still of total CPU available. So still a lot of room for handling stuff there. So that's basically it. If you have any questions, do we have time for questions?
We're a little over.
Okay. Well, if you have questions, come and find me, and I'll be happy to answer them. That's it. Thanks.